So we'll start now from the part 2 of the session, which basically talks about the compute and applications component, and then we'll conclude with the part 3, which is basically cybersecurity components in addition to whatever we have discussed in the previous session on the network components. So let's understand the elements of compute and the apps. So compute is getting replaced by the word which you will see otherwise servers. So easily this means that let's look into what is there as the elements of servers and apps. But in the current language or the discussion points, instead of using the server, now we have started to call it as a compute. So compute is the hardware element, and the apps are the ones which we all use or access to get our functions done. Now, once the network building blocks are there, obviously, as users, as the consumers of information, we are not interested in what a network is going to be delivering it to us, because that's not the end result. End result is delivered only when the applications are accessed by the users, or the applications deliver the information to us. So in that context, we are going to understand that the next important elements which let the applications exist or render those applications is the compute element. So in this case, let's see what are the different important elements. So one is the hardware. Hardware is typically the compute power which is used by the applications or which will be harnessed by the applications to deliver their desired functions. So that's a very simple language based definition of a hardware, that the applications will harness this compute power to run itself. Now the different abstractions which exist today with respect to hardware are standalone servers. We all know that, and on the server side these happen. Then the grid of rack mounted servers. So in the data center, we all know that there are racks. Inside the rack there are rack mountable servers. So this is also shown in the last slide of my previous discussion, that how a data center looks like when cooling and fans all coexist in one single rack. For the servers, multiple servers get rack mounted in a single rack, and so on and so forth. So that's on the host side or on the delivery side. Now the consumption side, where the people are consuming these applications, they would either need the desktops or they would need the laptops in a very specified function. And also there will be some kind of a local storage required to store the content, to store the data, etc. So this is like a hardware. Then we have operating system, which runs on the top of a hardware. The operating system job is basically to manage this hardware and peripherals, which are in the form of keyboard, computer, CPU, VGA card, or any other GPU for graphics, etc. All that hardware components, when they exist, how these hardware components will be harnessed by the applications. There is some middleware function or a middle level function which comes that manages them, that orchestrates their consumption for the applications, and that's what is called as an operating system, and I'm sure we all are aware. Also, the operating system handles the interconnectivity functions, which means these applications hosted on a server or the client level applications, when they are trying to go out of the wire, they will need to interact with the network plane. They need to talk on the network for IP address, for the MAC, and the data frame packet communication, which we have discussed also in the previous sessions. So this handling of this plane is also under the purview of operating system. So that defines the operating system. Then comes the third component, which is the most important component, and that's the applications. So we all know that these applications are the real business use cases. These are the real requirements which we need for a man to communicate with the machine or with the digital interface. So whether it is a Microsoft Office or a Microsoft Excel or e-commerce server or a payment gateway or a e-wallet, everything which we are seeing, these are the different use cases for humans, and these use cases are delivered through machine or a digital interface to us. So that's what is an application that comprises of this entire framework of delivery and user experience. Then comes the last component, which is the centralized storage. So in the era of huge data needs, where we are consuming, processing, and storing so much of data, all that needs, and that's happening across the industries, let me tell you, there is a huge need for a centralized storage for each of the organization that has a multiple user environment. So this all, if you look at, these are the four very important contours of the compute and apps to be put together. But I'm sure that if you hear somebody else, somebody else who is maybe as long experienced like me, who's a practitioner in the industry, they might break it down into further few elements. So I won't say that this has to be sacrosanctly followed like the way I have structured it, but this is how I have understood it. And I believe that most components which can further be further substantiated broadly classify under these four important functions. And individually looking at these functions, they separate each with each other. They're different looking elements. That's why I have classified them into four and not lesser than four. Then a very important thing which has happened over last about 15 years in the industry, which all of us are harnessing today as the users or the power users or the consumer of the technology, and that's the virtualization. We all know the first level of virtualization has happened in the form of a hypervisor. So I will give this term. We all, whether even if we are in the sales, pre-sales, consulting, or a research role, we all need to know that yes, a hypervisor is a term which is basically used these days, that has allowed the sharing of, and thus also allowing the multiple operating systems to coexist on a single hardware framework underlying these in the form of peripherals or storage. So if you look back in this slide, so imagine 20 years ago, there was a single hardware, and a single hardware could host a single operating system. And on the single operating system, then we were actually co-hosting multiple applications. So let's say the hardware was there, Windows 95 or a Linux Red Hat machine was there, and individually those machines will have maybe multiple applications. That is absolutely okay. Or a Windows 2000 server, which used to have a single hardware underlying it. And if I have to put a operating system of Linux on the same hardware, there was no way I could do that. But with the hypervisor, a single hardware which is a combination of compute, peripherals, and the storage, this can be virtualized by having to allow multiple operating systems to coexist. And that virtualization was actually attributed primarily to the proliferation of we know one very strong brand called VMware. So they have allowed us now multiple hypervisor technologies exist today, but the most popular one we all get to feel, believe is VMware in this context. While all we see today is, Evercent is there, KVM is there, Oracle is there, Microsoft is there. So there are a variety of other technologies which exist. ZenWorks is there. But if we look backwards, yes, that's one company which has actually did a landmark role in bringing this on to the individual user level. Then if I look from a server data center racks level, like the way you are seeing it in this slide, we can very easily see that um, when multiple operating systems will coexist on this hardware grid, there is a likelihood that we will reach one stage where the compute is no more available to put one more tenant on this physical infrastructure. So what do we need at that time? We need a horizontal expansion. So horizontal expansion means add one more hardware. It is like a cart which was having 4 horses, and now I am adding one more horse because I need more horsepower. Similar way, it is this rack which was having a capacity to add more servers, physical servers to that rack to give a horizontal expansion. So that also is delivered by the feature of virtualization. The third thing which it addresses or brings on the table is that it also helps us utilize the resources more efficiently. Why? Imagine if there is one single hardware, which is my laptop, which has one single operating system today. In my laptop, if I am not working for 9 hours in a day on Saturday, so this compute power and the operating system sitting on this is lying idle. Similarly, across the server side of the space, if an application is not being accessed, this is also lying idle. But two, if we are able to share this infrastructure with another operating system and another operating system and another operating system and so on and so forth. So what does it mean? That effectively we are expanding our utilization. Also, we are offering the elasticity. Imagine if I have bought this laptop and I am now expanding my needs of operating system and application on this laptop. But there is only one limit on which this hardware can be expanded. Imagine if it allows only a 16 GB memory, which means there will be one fine day when I will not be able to expand beyond 16 GB memory. There will be one fine day when I will not be able to expand storage beyond 500 GB, because that's the limitation of this physical device. But if it allows me to have a horizontal scaling, which means just by adding external memory or external hardware, it will allows me elasticity to expand as and when I require. At the same time, if I don't need them, today my needs have come down. I have removed 2 operating system. I have lost 3 customers. It means the same horizontal expansion can be reversed in shrinking that requirements of compute, because the same can be then redeployed or reused for somebody else. But in a single laptop or a hardware, this was not possible. But in the rack, which you are showing it on the right side of the screen when you're looking towards it, this is what exactly helps you build the scaling, auto scaling, what we call it as. So these features of auto scaling, these features of which come and attributed because of a horizontal expansion as and when I need. And that horizontal expansion is required because I'm co-hosting multiple operating systems, multiple tenants on the same physical infrastructure. So I can offer those elastic functions to them. Therefore, we are able to achieve all this by the virtue of something called as a virtualization in the bottom. So that's where the virtualization plays a very, very critical role at the level of hardware being virtualized for the operating system. Now I will read the last point once I finish what I have to tell you now. So far, we have talked about that there is a single underlying hardware rack framework or a grid on which we are co-hosting multiple operating systems. And we have been knowing that each operating system, be it Windows, Linux, can have multiple coexisting applications, which is great. But imagine that a server or a compute which is having application called Microsoft Office. So this Microsoft Office will be used within that environment by the respective set of users only who have been able to have a direct access on this application. So let's say these are all 50 users working in Bangalore, and from 9 a.m. to 7 p.m., everybody works because beyond 7 p.m., nobody is there in the office, and before 9 a.m., nobody comes. So imagine the time which is from 7 p.m. to 9 a.m. Even the applications which are inside this operating system are lying idle now. So what should I do now? Can I reuse these applications? Which means, though they are part of the operating system one, running on a virtual machine one, inside this hardware grid, but can I reuse this application in an operating system two, which is running on virtual machine two, because this operating system 2 and virtual machine 2 is being accessed by somebody who is in Singapore, and Singapore starts 2.5 hours before me. At least in that 2.5 hours, I will be able to efficiently reuse this application 50 user license of Microsoft Office. So how will I use that? So this technology where the application can be reused elastically, the way we have understood the operating system being elastic on the hardware. And furthermore, that's not just the definition, but from a very simple point of view, where the application is being virtualized in such a way that it can be consumed by anybody and everybody in that grid, no matter which is the platform it is coming from, whether Microsoft or from Linux or any other equivalent. Such application frameworks are the order of today, and such frameworks are called as containers. Containers most popularly are deployed in the industry today by a company, Dockers, or the framework Docker. So you can read the framework of Kubernetes deployed by Dockers or Kubernetes natively. You can read that and get to know more about this. Plus, I will be talking about this further in the last slide, bringing this topic again. So the level of application reusability has come by virtualizing the application itself so that it can be called from any framework, any tenant side. Is the containerization of the applications is another way, or containers being used. Some people may call it as a Docker, some people will call few other terms that we are going to see in the next few slides. So this is all about virtualization. So to summarize this slide, there are two levels of virtualization I have talked about. One, when you see all these physical racks, which can be allowing the hardware compute to be horizontally expanded so that multiple operating systems can coexist in a single grid. And as and when somebody who is using this operating system as a tenant no more exists or need more power, it can be given. So that virtualization of hardware allows, and peripherals and storage allows us to do so. So in the core of this business requirement sitting is the virtualization of hardware by the operating systems running on the top of it. The second virtualization is the application itself. Typically, application gets locked within the operating system is a typical scenario I have told you, which still exists today. So one server instance running in a one virtual machine on these physical infrastructure can have application locked to it in a very normal and a traditional or most common scenarios today. But the early movers in last 5 years have moved even one more layer of virtualization, and that's virtualizing the application layer so that the application delivery can be done to multiple tenants with the same application framework, and that's what is called as containers. Very popular is Dockers. So this summarizes the slide. So two kinds of virtualizations we are moving there. So these expanding virtualizations at the network level, which we have studied in our previous session, and some of the virtualization which I have demonstrated in my previous slide, has led to something called as evolution of data centers. So we will, this is a little busy slide, so we will spend a little time around this slide, and understanding this slide is very, very important for all of us in no matter which role we are in. Some of you who are already in existence in QS for some time might have seen this slide. That must have been my business interaction, but today I will deep dive into a technical framework. So let's start looking at this slide from the left side first. So and we will have at least two different types of runs on this. So firstly, I am having an infrastructure level run on this. Okay. So let's start looking from a left side towards moving the right side. So when we are doing an infrastructure run, we all know that the first thing that comes is the network. On the network will come a compute hardware. On the compute hardware will come the operating system, and on the operating system will come the apps. So this is the delivery of servers and apps. Beyond apps also come the data. Okay. So data is what exactly is getting either in the form of an information or a record, or in the form of a transaction that is for us, that is delivered on the top of apps. So we are ignoring data at least in this slide for some time. Okay. So let's focus on so far whatever we've studied. So network, hardware, OS, and apps. And that's what exactly you've seen until now, what we have discussed. In this previous session, we have understood the new word called SDN. So now I'm moving towards the right side, the first right column. So in a traditional data center, let's first look again what I missed, sorry. In a traditional data center, extreme left column, if you see, all of these are actually separate. You know, there is a boundary which exists between them, and they are one-to-one mapped, which means one underlying network. On the top of it, you will see a single hardware framework, and then in the single hardware, you will have one-to-one, one hardware to one OS, and in one OS, you will see multiple apps, you know, belonging to the same organization. But now, if we move to the private cloud is a new term which is being given to the next generation data centers around 8-9 years ago. In the private cloud, there is first of all no public instance, which means there is no Microsoft, there is Azure, there is no AWS, all those words which we keep on hearing. There is no Alibaba. It is my own bank. But in my bank, I am going to virtualize few things. So let's look at that gray colored network. So in the previous session, I have told you that the organizations have started breaking the switching layer to the routing layer. So routing is centralized while the switching is decentralized. So that's what gives the benefit in the form of something called as a software defined networks. Now, when this happens, this gives a birth to something very interesting. So imagine, which I'm going to show you in the network security slide, that when a packet moves on the network from my desktop towards the router, which we have seen in the last slide, it was going uninspected. Nobody was inspecting it, correct? It was just shown as, because connectivity was the objective. But in the future slides, when we'll start talking about cyber security, and we will say, okay, at least inspect it for antivirus reasons with antivirus, or at least bring a firewall so that I can understand which packet should leave my network and which should not. Also in the opposite direction, which packet should come to my network or which should be dropped. Very basic things which will be required. So what I will be doing in the future when we will be going to the cybersecurity slide, we'll be actually breaking the infrastructure between a switch and a router, and we'll be introducing this network security elements. While doing so, imagine now if the routing function is separated from a switching function. In the case of software defined network, and the security also needs to be delivered, and various other things have to be delivered. How are we going to do that is a question mark. So that is being addressed by something called as NFV, which is called as network function virtualization, which means when I'm routing the packet through the routing centralized framework, I will decide which is requiring a firewalling function and which is requiring an antivirus security. And accordingly, I will virtualize that traffic. Some tenants might require firewall as well as antivirus security controls. Some tenant applications or tenant operating system might require only firewall. So at the routing layer itself, because it's being segregated, I will decide, because the routing decides which packet goes in which path. So I will give somebody a path of firewall plus antivirus, and the other flow I will give the path of just the firewall. So that's what is a NFV. Because the routing and switching has been separated at the network level, virtualization level, so the new term has taken the birth called as NFV. So now in the private data centers, this had started to happen, that organizations had started introducing SDN and network function virtualization technologies, which by virtue of SDN were compulsively required. Also at the hardware level, we have also introduced a new term in the last slide called hypervisor, right? So in the hypervisor, we have actually shown that it is one single virtual infrastructure which is acting as a middle layer, allowing multiple operating systems to coexist on a single underlying hardware. So instead of a hardware now, we started using hypervisor, and the example I've shown you or talked about that was like VMware, like KVM, like Avocent, like ZenWorks, and so on and so forth. So or Microsoft Hyper-V or Hyper-V, all these technologies have been had replaced the standard or a standard hardware. Because that had happened, now instead of a single operating system, we have a multi-tenant operating system. Now, in the multi-tenant operating system, we could have multiple application delivery points, which will service each operating system from a single delivery point by virtue of Docker/Kubernetes. Also, I am introducing a new term called DevOps that I'm going to delve. So please just blindly read this, because this is a slide. Don't try to understand DevOps. I'm going to explain that in the later slides, but just for the sake of. So Docker and Kubernetes, I have already explained you that where you make the centralized delivery containers who will be consumed, elastically consumed by the different operating systems at different times, whenever they would need, or they will be coexisting and co-accessed by multiple operating systems on the underlying framework. And in these containers were running those real applications. You know, the application of core banking, application of internet banking, application of e-commerce, application of ticket booking or whatever, you know, those, or Zoom for that matter. And obviously on the top again comes the data, which is common framework. Let's say there's nothing which changed for data. So this is how the private cloud was built, both at the network level and at the operating system level. People introduced this. Now what started to happen when the data centers were becoming more efficient because now the idle hardware was removed, elasticity was introduced. It has helped that somebody working in different department does not need to have their own dedicated server. Instead of that, they started putting everything in a centralized data center and starting to give those idle lying servers, they have started optimizing them because of the virtualization. So if you go 20 years back, you used to see some servers scattered in different floors. But now most occasions, you will see they all have been put together in one single place and generally in the racks. And that's what also is having some kind of a hypervisor infrastructure. So this is very common in the current generation data centers. You would hardly see any organization today which is having at least, let's say, any environment of 20 servers and beyond, is going in a standalone way. So there is no standalone data center where any organization is having more than 20 servers. So this virtualization, elasticity, efficient compute, utilization of the underlying idle hardware or idle applications, this has given the new business proposition to the different service providers who thought that instead of a bank doing that for its own organization, let me do that for multiple banks, or let me do that for multiple pharmas, or let me do that for multiple pharmas, multiple banks, multiple manufacturing companies together. But will they give me so easily their data? No, they will not. But there are some applications which we generally don't worry about. To start with, mailing. I don't care where the mailing infrastructure stays till the time mails are in my personal control as an end user. So people started to build those applications in the similar manner, and they have taken that outside my domain. But in this journey, the first thing, it was not so easy to convince any bank or any pharma that, okay, start giving me your mail. They did not agree at the first place 15 years ago. So what these public cloud guys, they decided was that let's start something small. Think big that we will take them to applications, but let's start small and act smartly. So they started within this public cloud, said that, okay, let's give the first abstraction. Abstraction is one delivery model, which they call it as IaaS, infrastructure as a service, which means I will go back to my customer and I will tell them, boss, you do not need a hardware. I will give you the hardware. You just come in my infrastructure. And I will not require you to give me net. You don't need to invest into routers, switches. I will give you SDNs and network function virtualization features readily to you. Not only this, I will also give you a hypervisor, which means you don't even need to invest into VMware. Imagine now, for a company like me, if somebody says that I will give you up to a hypervisor, everything, you just bring your operating system and start your work. This became a very interesting proposition for me as a customer. So even if I am into very critical business like bank, I started to think that, yeah, at least I can take my mail server there. Yeah, now I will not give them to decide on my mailing as a mail where they are giving me an application end to end, but I can actually transfer my physical mail system, which is existing in my data center, eating my AC power, eating my network cables, eating my consuming my other resources. Instead of that, I will just ask them to give me an hypervisor and I will host and control these machines. That is how, if you see now, in between on the right side, I am showing you a service provider vertically written. And the boundary of this service provider in the IaaS goes up to only hypervisor. So hypervisor given, Now you bring, my dear friend, as a customer, your own operating system. You want to bring Linux, you bring Linux. You want to bring CentOS, you bring CentOS. You want to bring SUSE Linux, you bring SUSE Linux. You want to bring Microsoft, you bring Microsoft. You bring your own OS. You run your own app, which is Microsoft Exchange or SendMail or any other form factor of application, whichever you want. Within your own servers, which you are taking, you would like to introduce Docker, Kubernetes, whatever, it is in your own purview. You decide. So that's why you will see vertically the boundary defining a customer breakdown. That yes, this is what my customer is going to control. I leave my customer to decide this. So this way, all of a sudden, you started to see the company which was in existence for last 20 years, making huge losses, called Amazon. They launched a new company called AWS, or launched a new version of their company called AWS. And all of a sudden, in a journey of 2 or 3 years, they became a positive balance sheet company. And one of the very, very big company today, because this was a turnaround. They took the compute of the world. They took the challenges of networking of the world. They took that the readiness required to turn around your operating system, which will not require you to firstly look for a physical space, then bring in air conditioning, then buy racks, then buy servers, then bring somebody to do and configure and implement them together. All of this was no more required. But what was then done? They were given that on the Reddit thing on the platter as an hypervisor. And as and when you would want to remove yourself out of this, so Amazon gives that flexibility of elasticity on a mouse click. That has actually led to a cloud variant which became very popular called IaaS, infrastructure as a service. So when anything is delivered as a service, which means there is a start point and an end point which a customer decides. But if the customer will be forced to take a yearly contract, it is very difficult. So they made the buying also very easy for the customers. Okay, you come on a monthly basis. You pay me for a month. If you don't use it, you exit. If you want to expand it, I will allow you to elastically expand within the month, within this boundary. And for this elasticity, I will charge you on as is basis. So all these business models started to flow because of this architecture. The rest all we have already discussed, Docker's apps, there is no change which had happened. Then came a different proposition. Now, the leaders had already taken the initial leap. AWS was very strong. Then Microsoft Azure came. They also became very, very aggressive and started targeting a different segment of market. And they became very popular because of that. Then came different vendors like IBM, like Salesforce, who said that if the company is in the category of e-commerce, for example, it would need certain kind of applications to get and tie together. Okay. If the company is into manufacturing, they will need certain kind of applications to get tied together. If the company is into pharmaceuticals, they will require certain kind of set applications, which work together in an integrated way to deliver, correct? Now imagine this, just close your eyes and you will think, yeah, that's true. And when that happens, why let my customers decide application of his own? I might as well start giving those readily available frameworks. Okay, my dear friend, if you are into clinical trials, use this stack. This comes predefined, pre-bundled with certain set of applications which are used for genomics, which are used for mathematical computational models for clinical trials and so on and so forth. So now imagine the new set of companies have started to born who were competently great. They were having all embryologists, genetic engineering people, and they were all doctors working together, but they were not capable to think and imagine that, oh, they need to invest on operating system. They need to hire a networking guy to think and make the multiple tenants to coexist. Instead of that, they just started going to these platform ready functions, which are called as platform as a service. This is very, very uniquely orchestrated for different kind of businesses. So this has given a birth to different kind of option called as born in cloud companies. Now, Uber is interested in only taxi kind of applications, but Uber might be the first ones to have gotten into this kind of an industry. So they had hired all the great techies who would have done their own IaaS service on the left side. You know what I'm just seeing it, because they could afford to have all those technical guys. But when I am a company number 2, which is Lyft, I may not want to have my starting cost as too big. And Microsoft, Alibaba, IBM, all those vendors were aware that this market exists. There will definitely be somebody who will come after Uber to start a company, which is Grab, for example, which is Lyft for that matter, or for any other reasons, taxi for sure, which doesn't exist anymore, but was acquired by Ola in this country. So on and so forth. Now, how will these companies or OYO, which is now a hotel giant from India, do you think they have put in their own IaaS? No. They firstly started with readily available PaaS probably. Or if not OYO, maybe next one who is doing much smaller business than OYO, but still great to do in their respective geographies. So that's all was being possible because somebody understood that if I am creating a tech platform for a hotel industry, these are the only 5-10 things I want to be tying together. Now, obviously, these names, they do their way of interacting with the customers differently. So on the top of that, they can still create their own containers further. So the platform was ready and the containers were to be taken to the next level. So these companies, they came who could bring the common operating systems together up to bringing some very specific environments readily available so that an organization can start their companies, and that's what is called as the PaaS. That is platform as a service. And then they started moving these. Now look at the role of the service provider and the customer has got expanded. Now comes the last part, wherein you see that the SaaS model, I'm sorry for there is some small problem in this slide in the last 2 sections of service provider and customer. The boundary is not correctly placed. So before we move to SaaS, just take the boundary of a service provider going up to the PaaS level. So the customer is only the owner of his container and apps and data. So customer is no more owner up to operating system. Everything is owned by service provider up to the container. Now comes the last thing, which is the SaaS, that is software as a service. So herein, all these functions with multiple apps on the multiple containers, all are tied together. Only customer brings in their data and takes away their data. So for example, we are aware that the Google Hangouts or Google Mail or Microsoft Office 365, all these features are end applications delivered up to the customers. Only customer has is his presentation using Office 365, which is his own property, but the PowerPoint as an application is in the cloud. The Microsoft document which he has created or an Excel sheet which he has created as his price list as their own data. Rest all is owned by Microsoft. And you only pay for the use which you are using. If I am a subscriber or an end consumer, maybe that's a yearly model. But if I am a corporate who has 500 users, 200 users, 2000 users, 20,000 users, they all are delivered on a monthly based pricing. It means, again, I'm sorry for this. Again, a template has a little challenge that there is no role of a customer here. Yes, the data is still owned by a customer. Service provider owns everything up to the data, which means the application of mail, application of artificial intelligence, application of machine learning, application of MATLAB, application of Acrobat readers, everything is owned up to the service provider, the one who is delivering that to me. So this is how we see this infrastructure that has evolved. A new term in the public compute or a public cloud space had started to evolve, and that's my second run, which I would like to do. You see, there are three terms which are very common on the top, which have been defined. The data center. Data center means it's a traditional word which used to be having one physical location and everything is the way it is shown in that. In the evolved data center came the next term called private cloud, which was in the purview of the customer itself. Most of the infrastructure was inside the customer premises. When the infrastructure moved from customer premises to the third party service provider, it started to be called as a cloud and public cloud, sorry. And in the public cloud, the first abstraction where only infrastructure moved is called as IaaS. Then when the infrastructure environment moved, let's say .NET or the framework where I've told you the life sciences applications work together, all those examples which I have told you. So when those frameworks also moved along with the IaaS, where I started, instead of building my own framework, I started only bringing my app on the top of it. So all that has become the PaaS. In the PaaS, again, it is a public cloud, but with an abstraction of PaaS. Then we have the scenario which we have discussed in the last, that is all applications are delivered end to end, including infrastructure, including operating system. All is the responsibility of a service provider. Only data is mine as a customer. In such scenario, it is also a public cloud with a SaaS abstraction, software as a service. But in some research papers, in some technical definitions, the public cloud with the SaaS abstraction is also called as a serverless computing. So it's a deliberate reason I have put that as a serverless computing, because I wanted to introduce this term, and I'm going to further exaggerate this term in the next slide. So all this is there, and as I told you, this slide has two errors. Error number one, that when you are looking the PaaS in the public cloud space, the boundary of the service provider goes up to that dark gray area. That is from where the Docker / Kubernetes is starting. And the second error is that there is no customer shown in the SaaS case, while the data belongs to customer and everything else below the data up to the application is the service provider role. So I apologize for this confusion of the errors which are there, but I have since clarified it, so read them like that. So now, as I told you in the previous slide, that there are other evolving trends in the case of the systems which we need to understand, and one of the important things is the serverless computing. Now this is a situation when a business entity, let's say me as a bank, doesn't invest into the servers, operating system, as well as in the application. So none of them I have invested in, but I use these components delivered by respective service providers like AWS, Microsoft, IBM, Oracle, Alibaba, Salesforce, Dropbox, Red Hat, etc., or at all. So this is just the name which is being used, serverless. It doesn't mean that the compute will run without a server, because sometimes by just looking at the meanings of this, if I expand it by dictionary, it appears as if I don't need server to run computing. No, that's not true. I as a business entity doesn't need. So it's a business definition of a situation when a particular business, like a bank or a life science company or a agri-tech company, these tech words, whenever you see agri-tech, life sciences tech, health tech, or fintech, all these names, when you hear, imagine that they, in the business terms of IT compute, they are called as serverless computing based companies, which means they are not going to invest anything on the servers or their compute. They will only be picking up the right stack of applications. Then we have understood the word containers. The tech companies deliver their applications like core banking. Correct? Somebody needs this application. For example, I am a fintech company and I need a full core banking software. Or I am an insurance company. I'm let's say Policy Bazaar or equivalent of that. So I'm actually an insurance company, or I'm a hire a taxi company, or I am a rent a room company. You can always connect those names, which you see in your daily life. Each one of them you can attach to them. But as a tech company, QoS, for example, or any tech company who is actually not a bank, Policy Bazaar is not a tech company. Uber is not a tech company, let's say, for looking at on the top of it. But some tech company below them, or their own company or their own business entity, Uber has their own business function who takes care of their technology. Maybe Ola has their own, maybe Oyo Rooms have their own, maybe Policy Bazaar has their own, but somebody else, let's say mywallet.com, may not have its own. They will go to this tech company called QoS Technology, for example, who will create all these packaged together. And when it will create it all as a business application for core banking, or business application for insurance, or business application for hire a taxi, QoS is enabling mywallet.com to launch its business tomorrow morning. But do you think QoS is today doing it in their own? No. They will just be orchestrating together on Amazon or on Azure, because they will also not put their own infrastructure. So these tech companies who are bringing these applications together are the container companies. Okay, so they are called as container companies, who will package all these tech apps referred to as containers over the serverless computing environments and deliver it to the customers. So why I have used QoS Technology, while QoS Technology doesn't do it, but there are many companies who are startups like QoS Technology who are building these containers and delivering it to the respective business entities. Then comes the last term, DevOps. Since these containers, so firstly I will read that for you. Since these containers, which are used for app delivery, are delivered as tech platforms to be consumed by the companies who are going to deliver their business channels, like banks, insurance companies, or e-commerce or e-wallet companies, etc., who will have in turn further their own consumers, will need a continuous development of the new features and the user experience. This market is so volatile now, imagine, because everywhere there is a different service provider, as opposed to a full-fledged data center when everything is with me. Now, within the infrastructure, I will have a service provider 1. For the containers, I will have a service provider 2. For the applications, we'll have a service provider 3. And I am actually a data guy who is only an insurance company. Okay. Who has bring in the business logic, the business use case. So there are four entities: service provider A, service provider B, service provider C. Service provider A is providing, let's say, infrastructure, which is, let's say, Amazon in this case. Service provider B, which is giving the container, let's say, for example, Salesforce. And service provider C, which is a company like QoS Technology, which is using Salesforce framework to deliver the e-wallets. And the actual customer or the corporate who will buy this with the virtue of all these three service providers is a e-wallet.com company. And this customer will further sell this e-wallet services to consumers, like the consumers who are going to use this wallet. So in the entire business proposition, you have seen 5 different layers. Layer 1, the infrastructure service provider. Let's fix it like AWS or Azure or Alibaba Cloud. Level 2, another service provider who is giving a framework, Salesforce. Level 3, service provider like QoS, who is going to bundle both. Using Amazon infrastructure, it will take the Salesforce framework, and then he starts writing the applications, business applications, which are required for, or combining those business applications required to deliver the insurance policies or compare the insurance policies. Write all that business logics and is ready to sell it to another customer who is actually into the insurance business. And then when the insurance business company and the QoS Technology belong to a same owner, then it's like Uber, it's like Ola, it's like who have their own application stack also, and they have also their business goals to achieve because they go directly to their consumers. But a smaller company will have only all these 4 being delivered by 4 service providers. In either scenario, okay, where all these 4 services are delivered by service provider, 3 services are delivered by service provider, and then there exists a business guy who is running that business, and then there are 5th, which is the consumers of that business. Or there is a scenario which is with the large companies like Uber, who have only service provider A for infrastructure and service provider B for the frameworks, and then they will have their own tech team to orchestrate these containers together, and they are also into the business of taxi, in the business of hotel booking or whatever. So in either of these 2 business models, all the consumers who are existing in the end, who are consuming these business services through business channels, they expect today very advanced features. They expect a great user experience. So there is a new term which has come into, which was not very popular, although it is been into existence, where the focus has started to build is a user experience, UX, or a user design. So all these features, which are expectations, are so moving fast elements that they need a continuous development now. All new features, just one feature coming, the business guy wants to render that feature to its consumer so that their consumer continue to get aligned to them. The affinity needs to build, and the affinity today exists only for a mouse click difference. So the people who were using Paytm may start immediately using Beam the day it was launched, while Paytm never imagined that yes, Beam will go that popular, but that had happened. The moment Google has launched Google Pay, there are many people who are using that. Paytm might not have envisaged that, but that's how the businesses keep on coming. So they would want to deliver new features every now and then. Hence, The development cycles do not have a luxury to continue to spend time in building these features and fine tuning these features and validating these features on a real run for a quality. They just need to be developed, tested on the flight, and delivered on the flight. All this is happening because of underlying of virtualization. Who has given and brought this environment in last 15 years from where it was 15 years ago to what it is today? Somebody has imagined this state 15 years ago and started building that small blocks after the blocks. So that's what I will call when I was telling you that start small, think very big, and act smartly. So this is how, as a smart world, we have brought in last 15 years the journey of compute to something called as the function of these three terms: serverless computing, containers, and DevOps. It's an irreversible trend. You like it or not, this will not going to reverse. So these are the terms you will continue to hear. If you can very well route a packet, which you have seen in the morning session or a early afternoon session, sorry, but you are struggling for moving a packet when it gets virtualized or is in the serverless computing or in the DevOps or a container space. Let me remind you, as a security consultant, you will not be able to exist for a long time as a successful career. You need to embrace these teams, and these teams have to continue to challenge you to start building security around them. While I have segregated them at a very initial level, these are very deep subjects. And anything, as I told you in the beginning introduction of what we are as QoS in a session 2 days ago, I would like to mention that very clearly to you guys, that the customer needs to hear these terms. Customer is talking and spending time in these terms. So you need to find out the solutions that exist for this. So let's check this, that what are the opportunities that exist for us when it is coming to goals of cybersecurity from a compute and a apps context. So we have to, first and the foremost thing which we have to do whenever we are planning for applications and server compute together, is that we have to ensure the north-south security. North is internet and south is my own infrastructure, my network, my trusted network. So we have to protect all our assets against the threats that exist owing to the surface of my network that is exposed to the internet. So the surface that is exposed to the internet has to be shielded well by the function of something called as a north-south security. That's the first thing first. So it's one very big opportunity which exists. But this is pretty matured in last 20 years journey of cybersecurity. Having said that, I still solicit that all those who are just beginning the career now and are not aware, they have to spend a lot of time in understanding north-south security because it is pretty matured. So, but nobody in the customer space gives you a very easy meeting if your starting point is that you want to talk about north-south security. So that's another important, interesting thing I have to tell you. You will not be able to understand the entire security until you start from north and south security. Understanding that is very important and mandatory, but that's just a starting point. It will not let you have a customer meeting if you only talk about that. Okay, but very important. That's why I spent few minutes extra on this one symbol first line. Second, achieve the protection against lateral attacks, which means if a single server or an application on the respective server gets compromised, okay, just close your eyes and imagine. If either a server gets compromised or the application which is inside that server gets compromised, then it will risk the others laterally, which means there is a risk which will move from one application to another application on the same operating system, or from one operating system to another operating system, or one server to another server. In the evolving data center, with an extensive virtualization that you have seen in last 2-3 slides, this is referred to as east-west security. So earlier I introduced the word north-south security, which also is called as perimeter security. So north-south security is also called as perimeter security. The lateral security, or a security to defend against the lateral attacks, is called as east-west security. Now, until and unless the abstraction of the risk is only up to the infrastructure level, the east-west security is a good term to be used. But the moment you get into an abstraction of a network or the applications which is using DevOps, which means the container also belongs to some tech company or my own tech company, which is different than me as a business company. Okay. So business companies, which is using business logic, tech companies, which is maintaining the platform for business to be delivered. Okay. That's how also you can understand. So when I was explaining you Uber and Ola example, which means their business and a tech company exist under the single umbrella of a logical or a legal entity. In maybe smaller companies way, it might be two different legal entities. But in either of those abstractions, the most important thing is that it's the DevOps which is happening. When the development and operations are moving at a continuous speed. There is no specific luxury time for development and do a validation on quality assurance and having a feature to be seen. It is just build the feature, test it quickly, and put it into the production. It's like the half life cycle immediately moving to the full life cycle. So if we have to enforce the security in that framework, that's called as DevSecOps. Some people may call it SecDevOps. Some people call it DevSecOps. These are two same terms. Till the time you see them into this Hungarian notation, these three words or these three acronyms together, it is the same one and the same meaning. Okay. So SecDevOps or DevSecOps is one and the same thing. That will impart the security at the container level. So your customers will talk about these terms. You know, what are you doing for east-west security? Do you have any solution on DevSecOps? Okay. So east-west security is a larger subject. Under the same, the subset is DevSecOps. So in the east-west security, even the infrastructure, which is the operating system, tenant level security, application to application risk level security, also need to be visualized or understood. Customer may understand these are two different terms, you know, they don't have any relationship with each other. But for you guys, east-west is a larger perspective. DevSecOps is a underlying umbrella only up to making sure the container is taken care of security. And all these DevSecOps, east-west security, these are technical jargons. The most simple language used by layman is called as give me the lateral security. Okay. The protection against the lateral attacks. So now I have summarized the point number 2 in all perspectives for you guys. So this is a very, very big and the second level of opportunity which exists with respect to applications and servers for us as the cybersecurity professionals. Then comes the third point written on this slide: strengthen the administrators. Yeah, because these are servers, these are applications. Both will have their respective administrators who will manage and maintain, you know, the server environment or the application environment. Now, these folks will definitely have more than user and a power user access privileges. Also, they will be logging in or getting into the system as administrators. So their authentication and authorization levels, you know, same authorization level, somebody will be able to read the logs, somebody will be able to just do very small level of configuration tasks, somebody will be able to do a higher level of configuration task, some will be able to create another user for administration. So all those tasks, are called as different authorization levels. All these functions of administrative access are also rendered or called as privilege access tasks. Hence, we need to have either a real-time privilege access management system, or at least we should be recording all these events so that they can be audited later. So the same term which I had introduced in the previous session in the case of networks, PIM and PAM, that is privilege identity management and privilege access management. So these are the solutions which are to be delivered by the security functions, so that the privilege access can be controlled and monitored. Then also in the case of servers, the users, beyond users, administrators are accessing them. When the users access them, they use the application layer, which is HTTP, SSL, or any other mail layer. But the administrators, they want to access those servers. Now imagine if these servers are lying inside Amazon cloud, or they are lying in a data center which is remote. So remote administration of these servers is a very, very common process. But remote administration means also that somebody sitting remotely can actually create a chaos or a complete havoc in my infrastructure. So some very highly secured environments expect the remote administration also delivered through something called as a jump server, which means you will absolutely not show what is inside your infrastructure to the remote user. But for the business administration perspective, for the server administration perspective, somebody will connect on a jump server, which is like a sandbox or a reverse proxy server, who will take your connection and initiate a new connection to the server for remote administration, so that your each function can be recorded. And in some very, very highly critical environments, even these sessions are video recorded. And not only video recording also have an anomaly detection, which means anybody who is supposed to do these 4 tasks in a sequence, if he introduce a 5th step somewhere interimly or in the end, it immediately send an alert to somebody else. So these are very smart solutions for remote administration, which is also a very good opportunity or a big opportunity for cybersecurity consultants. Mind you, all these opportunities does not mean that all will be delivered as a service or a solution from QS. This I am giving you as a broader perspective, which your customers might talk. Even if you are going as an administrator or a delivery guy, or like a delivery engineer or a professional services engineer or a consultant or a blue team, red team, purple team person, you need to know this. Then comes the 4th opportunity for the cybersecurity folks, and that is basically the configuration assessments, that we are going to do a security audit to discover and remediate the configuration faults. 5th one, somebody like was targeting networks and we were calling it as a network DDoS. There is a likelihood that somebody might target these server compute applications, etc. And this will also get classified under DDoS. So we have as a security company or security consultants, we have to look at that somebody can, either QS or somebody else, can perform DDoS simulation. Also, the servers have the vulnerabilities, because servers are running some operating systems, some applications, and those vendors keep on publishing their vulnerabilities. So a continuous or a monthly or a periodic, quarterly, yearly, whatever, vulnerability assessment has to happen. And then also the penetration testing. So vulnerability assessment means a company will do a process by some tools to validate what all vulnerabilities exist on these applications / servers. However, penetration testing validates that even if there is a vulnerability that exists, or even if I combine 2 different vulnerabilities and connect them through some mechanism, I may be able to penetrate inside the application or a server or an infrastructure, and that's what is the penetration testing. All these services of DDoS simulation, vulnerability assessment, and penetration testing is another one scope under the cybersecurity framework or delivery services that the compute and applications expect. Now comes the very interesting part. All these applications, servers, etc., at the end of the day, nobody is interested in Gmail. Nobody is interested in the a ticket booking application. Nobody is interested in what IPL application has put. Everybody is interested in the analytics. Let's say I want to see who is my best player. So I want to see the output, finally outcome of those applications by virtue of crunching the data or delivering the data or generating the data or taking my data, whichever it is. So at the end of the day, the most important element is the data. The most critical crown jewel is the data. Data is the most critical asset. Another important, these are terms which people are using or phrases which people are using across. In either case, the data might belong to me as a person, or data might belong to me as my role in my company. So there are two kinds of data which I as an individual deal with primarily. The loss of data, which is also called as a leak of a data, or probably underlying with many days somebody was stealing the data slowly and gradually, which is called as a data breach. So preventing a data leak and identifying the data breach is also a very important area for with respect to applications and servers in the context of cybersecurity companies. Then we have put all these servers, we have put all these applications, people are accessing them, they're getting consumed. Somebody has to monitor them because they have wealth of data. The data for analytics from a security perspective. Who has accessed at what time? Imagine there is a SQL server which generates a 500 MB of transaction log every day at any moment of the time, because we are into a 24 hours business. Imagine. Now imagine if the transaction log grows all of a sudden from 500 MB to 600 MB, and system alerts. Somebody validates, oh, today is the IPL ticket auction. That's why people have come at 1 PM on this. Good. That's a nice behavior. We will ignore this alert and the system will learn. Next IPL match auction, again tickets happen. Again we see 600 MB. Good. The system now no more generates the anomaly because it's now a well-known learned behavior. But on the day 3, we have, instead of 600 MB, we have 1 Gbps. No, 1 GB of data is being processed at the transaction log level. Now, this will generate a big alert. And when we will start investigating, oh, we figure out, oh, this is the final, yeah, that's why you see a huge rush for that. Okay, understood. But then when we understood that final should have only increased from 600 MB to 800 MB, that means there was additional 150 MB which came. And once we realize and understand all that, we figure out in the real-time monitoring that that 150 MBs was all the bot traffic. So all this is basically a real-time monitoring which will bring this visibility. Otherwise, we will never have this visibility. Now, every organization goes for this visibility? No, not necessary. But for sure, there is an opportunity which exists because of that. And once we are doing this real-time and log collection, then comes the last possibility that yes, we will be able to do forensics should any breach or a data application compromise happen in my organization. Then if we are doing real-time analysis, it's just like, you have a camera surveillance, and surveillance helps you do forensics because it will have some evidence recorded in the past, which you might have ignored in the real-time monitoring because it might not have been that big. But once the attack has happened, once the breach is realized, and somebody has to do now investigation, you have a logical or a equivalent IT event. That's what exactly gives you a possibility of the last scope, and that's forensics. Maybe folks, I have enjoyed this, having spoken to this, because I'm doing it maybe after a very long time. So I didn't realize that I would be taking this long, 1.5 hours. So we are parking this third subject, which is very interesting, because I believe a lot of information has come. There is a lot of work for you to do in the weekends before we do this third part. I will announce we will do it on Monday, most likely. If the situation owing to coronavirus goes bad, and we'll have certain announcement comings for in any which way, then we might as well postpone the session from Monday to Tuesday. So no matter where you are, stay safe, stay happy, and I'm sure we still have 10 minutes. Not 10 minutes, but I can stretch it to 10 minutes for taking some questions. So I'm parking this subject of part 3 for the next day, as I told you. And I hope that you guys would have enjoyed this. I thoroughly enjoyed, for sure. So you can start typing or asking your questions. Somebody wrote to me, can I pitch in with the interesting anecdote on DevOps? And as I was saying that I will not be seeing the chat, so maybe I've missed that. It's Rahul, sorry. Rahul, you can, all yours if you would like to add somewhere. I'm sorry, I was not looking at the chat, but this was in the chat. Okay, maybe anyone else? Any question, anything? Any comments to improvise this?
Yeah, it was good, I guess, sir. Like, so far, like, it's not, too high or too low, but it's good, I can say.
Okay. So I've got one question. Is NFV and SDN work on the same principle? I will come back to answering this in a short while. Rahul, you want to speak? I'm seeing a hand being raised. Okay. In the meantime, I try to answer this. Okay. Look at, first of all, the principle of, the answer to this question is yes and no. Okay. Because your question is NFV, which is network function virtualization, and SDN, which is software defined network, are they working on a same principle? This is a question which is there. So I said the answer is yes and no, because firstly, let me tell you why yes. Yes, because they both are actually harnessing on something called as virtualization. Now let's look at why no. Okay. Let me show you something, because I said I will be doing it tomorrow. To answer this question, I will use this slide. Okay. Now you can see that the Windows client, Linux client, LDAP, VMware, ESXi, Wi-Fi, all connected to layer 2, layer 2 going to router, router going to wavelength division multiplexing or MPLS connector, that is taking us to internet, and then there is a subsequent internet, correct? So that's, let's say, this is a diagram which is very typically no security right now deployed in this. Okay. Now if you see wires of the router, there is one in and one out. So one north, one south. That's why it is north and south communication. Okay. Now let's look at the next slide. Folks, I will be explaining this again, but since this question has come and this slide will help me answering it fast, so I'm using this. Now let's look at this, the modified version of this diagram. Now see, there is one new element which is called as I in the brackets, correct? On the top, after that blue line dividing the screen. That's called as NGTP appliances, that is next generation threat prevention appliance. Now if you look at this, what it has done, it has actually broken the north and south, which was directly connected between router and layer 2 switch, and now it is making it pass through this network security device. Since it was single line of wire, I could actually do that very easily. But imagine the VMware ESXi, that orange color in between that on the left side, you are seeing that. Imagine there are 100 tenants on that machine. Tenants means I am a cloud service provider and I am giving the compute services or infrastructure services to, let's say, 100 customers, and all those hundreds are existing on this VMware ESXi. Customer 1, customer 2, customer 3, customer 4. I hope you guys can visualize that. If you look at the security which this NGTP is providing, all 100 are provided with one level of security only. That is it. And I will not be able to deal with this if one gets compromised. So what should I do? I should bring in some VMware level security. So we will be explaining that in future. Okay. Now coming back to SDN. So first of all, this is all because of virtualization on the VSX. That's why the SDN is and NFV are common. In the router, when the router itself, which is F, device F, when it is broken into two parts, and there are multiple routers, again, some is coming, bringing customer A, customer B, customer C, somebody is bringing customer 100, customer 101, customer 102, so on and so forth. All this will get virtualized at the routing and a switching function level because of SDN. So imagine now some customer who is sitting inside the VMware wants to have only the firewall capability of this next generation threat prevention server. And he doesn't want to pay me for antivirus protection. I will not be able to deliver that by just doing a SDN. Because even if the SDN has happened, because this kind of a physical connectivity, I will be forced to do protection for all or protection for not all, or in a very limited way, some way I will be able to bring some workaround, but this will not be a very flexible model if the SDN is introduced. So what I will do? I will have to, at the SDN level, enhance the SDN configuration that when you are sending the packet to customer 100, enable the security function of firewall. When you are sending it to customer 54, enable for antivirus as well as firewall. This will be written. Now to do so, NGTP has to be NFV aware, which was not the previous case. So in the network nutshell, when we virtualize the entire end-to-end network security as well as network component, it is called as NFV, network function virtualization. But when we leave it only to routing and switching, which is much more simpler, then it is SDN. So I would say that SDN is a building block towards the NFV. Okay, not that NFV and SDN, they follow the same principles. I hope I've tried to answer this. but I will be, bear with me on Monday or on Tuesday, whenever we will do this session, I will delve this again.